The next step is to double click on pump and then put differential pressure 50, and then click the next pump, differential pressure 50 psi, and then the same thing with this differential pressure 50 psi. Then click on choke, enter pin size 1, then let's see what is happening with this one. The ESP while is not showing is indicating error. So let's bring the well again and click OK. So now we connect another one. And then we enter diameter to be 4, 0, 50. And we have to delete this one. Have to delete this one. Also delete the flow line. The next is this one, the natural flowing well is showing error. So let me see what could be the problem. Could it be the name? So this was the name. that give us that error. Wow. So change it as natural flow 1 and this one too. ESP ESP1, and then the choke ESP. So the choke and the well must not have the same name. Let's take note of that. And here we have natural flow. Oh wow, this was supposed to be gas lifts 1. Alright, everything is fine now. So the next step is to produce our well. Go to home and run nodal and network simulation. So here we are going to enter the wellhead, the pressure here to be 200, the storage tank pressure to be 200, 200, 200. Now we can run our simulation. Now this is our result. Now let's quickly see the storage and see whether oil, we have gas separator, we have oil separator, and we have water separator. So the three phase separator separates gas, oil, and water. So let's see, under gas, there was no gas, there was no liquids, oil 0, water 0. Then gas is 10,000 million stock-ton barrel, a standard cubic feet per day. Then for oil, we have about 7,860 stock-ton barrel of liquid, and then oil is the same value, 7,860.783 stock-ton barrel of oil per day, and then water is 0. So there was no presence of water in oil and gas storage tank after separation. We still have remnants of gas in oil after separation, so we need to pass through another stage of separation. Then for water, we have about 3,197.349 stock-ton barrel. Then oil is 0. and then water is the same volume. So water tank contain no oil and has no gas content. So the 3-phase separator was able to separate oil, water, and gas. Then we can also look at the performance of each of these wells. So ESP well produces about 2,052 stock-ton barrel of liquid. So let me look at the oil. ESP well produces 1,437 stock-ton barrel of oil. Then gas lift produces 1,467. Then horizontal well produces 3,149. Then natural flowing well produces 1,800 and 1,800 and something. Wow. So that is that. So let's quickly look at the natural flowing well we use. The flow rate is supposed not to be higher than the horizon than the artificial lifted wells. Let's see, look at the water cut the well was producing under, and then look at the reservoir pressure to know, to confirm that it is the same well we were using. Alright, so we go to nodal analysis. Wow, so reservoir pressure here is at 4,000. No wonder the well is producing under natural flow higher than the the gas lift and ESP. And then the water cut here is 25%. And then, so that is, these are the reasons. The reservoir pressure under artificial lift wells, we were using 3,500. Then water cut 30%, then increases to 40 during the simulation, during the sensitivity analysis. So ideally, we're supposed to use the same well. Maybe in the next example, I will rebuild or remodel the natural flowing well, and then we do the comparative study of natural flowing well under vertical, horizontal, gas lift and ESP well. Thank you for watching. Do have a wonderful day.